Okay, good morning, everyone. So let's begin. So this is the 14th PAASE webinar. Our lecture is entitled 3D Printing Advanced Materials Additive Manufacturing for STEM Disciplines and Innovation. Our speaker for today is Governor's Chair at University of Tennessee and Oak Ridge National Laboratory. He is also a research professor at Case Western Reserve University and a fellow of the American Chemical Society. He is a fellow of the Polymer Science and Engineering Division, fellow of the Polymer Chemistry Division, and he received the Distinguished Herman Mark Scholar Award in 2013. In 2018, he was elected National Academy of Science and Technology Philippines, and he recently has been appointed to the World Economic Forum Advanced Materials Council. He is the editor of MRS Communications and Reactive and Functional Polymers and has held a number of visiting professor positions, including Waseda University in Japan. His group does research on polymer materials, nanocomposites, colloidal science, 3D printing, hybrid materials, and ultra thin films towards applications from smart coatings to biomedical devices. He is very passionate in mentoring students and helping other countries in their STEM programs. So, without further ado, I'd like to introduce you to Professor Rigoberto Advincula. Okay, Gobet, you may begin.
Well, thank you very much, Kathleen, for that very generous introduction. And I'd like to thank our PAASE members and officers who are joining us today, and also in the future for other listeners who will be watching and listening to this uh, presentation. So, yeah, I would like to talk about 3D printing and um, Industry 4.0. So it's a little change on the original title that Kay mentioned. And also, I would like to focus on some of the things we have been doing in the Philippines. As Kay mentioned, I recently moved to Oak Ridge National Laboratory and University of Tennessee as governor's chair. But most, if not the engagements I've had with the Philippines was, of course, carried when I was at Case Western Reserve University. And I still have my appointment there. In fact, I still have 5 PhD students as well as my laboratory there finishing up. So let me start by showing this collage of what 3D printing, additive manufacturing, rapid prototyping, Industry 4.0 means. This really is a paradigm by which additive manufacturing has taken over many types of fabrication and supply chain um, ecosystems that will transform industrialization in any country, actually, but more so with in combination of things like artificial intelligence, machine learning, block supply chain models, and so on. So yeah, I hope you will gain some of this insight as we go along with describing what industry means in terms of additive manufacturing. So back in 2016, I gave this talk at the World Economic Forum. I was invited to give a talk on describing the future of additive manufacturing. And there I laid out many things that I observed then, that this ecosystem will bring much difference in how we do design, manufacturing, even in space, tissue engineering, bio-inspired design, different types of tooling, as well as fabrication or production of um, tools and even lightweighting. So we are familiar with 3D printing. If we simply buy a $200 3D printer, that's sufficient to start. Yet many types of 3D printers today can be tuned for mass production as well, and different types of chemistries. I like to show that one of the things that amazed me with 3D printing is that uh, one is able to mimic nature. In fact, looking at things that you can generate by computer or imaging one can translate this to different design principles, biomechanics, and so on. 1997 actually was my first introduction to 3D printing. So even back then, more than 20 years ago, 23 years ago, uh, they were not using the term 3D printing, but at that time, I was made familiar with the term stereolithographic apparatus, or SLA. So this type of photopolymerization, two-photon polymerization, is very efficient, such that you can do lithography or fabrication at the nanoscale, or several hundred nanometer resolution, as you can see here. And this makes use of photo-cross-linking chemistry using two-photon resonance, or what they've used for some imaging systems. On the other hand, what is really been gaining ground is the application on prosthesis or thesis, dental devices, bioimplants, bone replacement. As far as 3D printing is concerned, many types of companies have recently been formed, especially in the development of technologies that can be applied toward um, tissue engineering and implants as well. And the beauty is that one, again, can take imaging, whether it's MRI, CAT scan, CT tomography, and then use that to translate that image into a CAD file that can be 3D printed with various types of materials, biomaterials. The beauty is that one can play with the design and the material approach to make the printed device very specific for the person, or a real gateway toward personal medicine. One of the bigger promises too is in the area of tissue engineering. Bioimplant is an extension, bioprinting is an extension of bioplotting. One can differentiate cells or simply 3D print live cells that can be used to grow tissues. And as you know, growing a liver, a kidney simply means that you have vascularization and tissues that survive and proliferate uh, into larger constructs or mass. Yet, in the area of aerospace and lightweighting and automotive, one of the best uses of 3D printing is improving the design and efficiency, aerodynamics, as well as um, um, efficiencies of electric vehicles. Surprisingly, 3D printing is finding its way in resurrecting old designs or even parts replacement, something that I'll describe to you as being very useful in the Philippines. 3D printing is also making its way in construction. So 3D printing of cement, civil structures, different types of um, fabrication for emergency response. Basically, 3D printing can go to very wide area uh, construction. Now, 3D printing is also present in art. About 4 years ago, I came across this project, a collaboration between ING Barings and Microsoft. And if you recognize this is a picture of Rembrandt. So Rembrandt, of course, is the famous Dutch master. A lot of his paintings you cannot buy, but they are available in museums. So what they did was they simply asked, can we use 3D printing, artificial intelligence to resurrect Rembrandt? So what they did is they collected as many as they can of the Rembrandt or the master's paintings, uh, deconstructed the symmetry, the depth of the paint, the layer, the shadows, the style, etc. Plug it in to an algorithm and started printing something. That's something which was printed by 3D printing, not by inkjet printing, because it involves layers of materials and paint, resulted into a painting which looks like this. So this is a painting which Rembrandt would paint today if he were alive. Out of AI and 3D printing technology, this is another way to resurrect, if not create, new designs that are influenced by previous masters. Now, 3D printing, probably in its most practical application to industry, can be used for rapid tooling, mold, design, tools, gauges, press, casting, thermoforming, embossing materials. That is, 3D printing can yet play a role in industry, especially in the Philippines, to improve mass fabrication or what we call formative manufacturing. The reason is that some of these tools and implements are very expensive and hard to fabricate, takes a long time, but 3D printing short circuits the process by making it digital. Again, I'll explain to you later why this is so important for the Philippines. So what you're seeing with these examples that I gave you is that additive manufacturing or 3D printing is not your typical fabrication process such as injection molding, thermoforming, or what we call formative manufacturing. That is by design, they are able to make complex objects, complex designs in objects, as well as improve material properties. They are not for typical conventional manufacturing simply because the ecosystem is not yet there. So, for example, when we talk about cutting, casting, injection molding, you have big lot sizes up to millions. On the other hand, additive manufacturing is good for making 10, 100 pieces, or even 1,000 pieces. So, suffice it to say, there is a real manufacturing gap. However, meeting that gap is not really the biggest interest. The biggest interest is differentiating additive manufacturing from traditional manufacturing, which is higher complexity and high performance materials. So for some of you who are familiar with the terms FDM, SLA, SLS, these are of course acronyms of 3D printing techniques such as fused deposition modeling, stereolithography apparatus, selective laser sintering, etc. These are probably some of the more common methods of 3D printing. And again, they are available commercially and even at the right cost for hobbyists. There are problems though with 3D printing. One of the weaknesses of 3D printing is because of the layering method, they are subject to defects and failure mechanisms based on the poor adhesion of layers and anisotropy of the build, build-up process. So unlike your injection molding, which is, let's say, a monolithic process, building these layers can cause defects and failure mechanisms. So for example, selective laser sintering is a method based on fusing powders that can be addressed by programmed CNC movement and a laser uh, powerful enough to sinter even metals. So for example, in metal 3D printing, as you see here, one can create complex objects and designs with different alloys and can be based on selective laser sintering or plasma methods and so on. Metal 3D printing is very important, yet is not as widely available as polymer 3D printing, simply because they are expensive. But in terms of value, of course, it can go into things like jet engines or very high performance automotive components. And the raw materials could be powders, could be wires, could be different types of hybrid materials as well. SLA is what I've shown you earlier in terms of lithography. It makes use of resins that actually can be the same composition as used in dental cement, yung pasta. And then it's also used for coatings. But SLA and DLP are some of my favorite methods. Why? Because the chemistry is rich and you can do a lot of nanocomposite formulations. And most of all, it has the best resolution. As you can see here, the parts are smooth and you can have very complex geometries. However, one of the most versatile methods of printing is what I call viscous solution printing. So this is basically the way they 3D print cement or chocolate or any paste extrudable material that can be formed into a shape simply by injecting or extruding an extrudable thixotropic material through a CNC movement. Other types of instruments that are popular are based on binder jet, resins, and UV curing. So there is a move to create farms, production farms, or big build volume 3D printing. And this is how they are meeting the manufacturing gap. So one of these days, instead of using a typical injection molding line, uh, parts can be 3D printed using a 3D printing farm or an array of 3D printers, and they can pay for itself in terms of uh, uh, cost and high value adding. Um, Here, this just to remind you that one of the avenues one can 3D print are images that have been obtained by scanning or even conversion of digital information from things like MRI or CT, PET scan, different types of tomography, or even biomedical imaging to convert them into a 3D printable file that can be converted to a STL file with an optimized code and then simply 3D printed in most formats. So emphasizing polymers and materials, my real background in terms of materials technology. When we talk about polymers, we are talking about thermoplastics, rubbers or elastomers, and thermosets or epoxies. Thinking about plastics, most of the plastic that we encounter are really commodity polymers or plastics. However, there's a class of polymers or plastics that are very hard to print. They really form the apex of this pyramid, as shown here, simply because these polymers are high performance, high temperature, and therefore quite challenging. Yet they are very suitable even for metal replacement. So, for example, as you can see here, a polymer like polyether ether ketone has a very high tensile strength. However, it's expensive. On the other hand, what competes on the thermoset arena are what we call polyimides that have also high tensile strength, but also high value. So the challenge really is to find the right material and a right cost with a 3D printable format. But we are not limited to plastics, as I've shown earlier. You can 3D print metals, you can 3D print cement, ceramic, other organic materials, food, anything that can be converted from a powder, a plastic filament, a pellet, or an extrudable paste. And this is really where it's going to industry. In the future, there are many industries like oil and gas, consumer electronics, aerospace, automotive that will require new materials and 3D printing formats in order to uh, improve complexity or even simplify the number of parts that have to be put or welded together. Some of you may even wonder if recycling has a place in 3D printing. Yes, the answer is yes. Definitely, plastics are recyclable if one can create filaments or composites out of recycled plastic and then 3D print them. Yes, they are useful for remanufacturing. And the question is, how do you make filaments? Well, filaments can simply be made by extrusion or different types of um, mixing, extruding systems that can produce fibers or filaments. Rubber, for example, is a challenge. 3D printing elastomers and rubber is something that we have been doing in order to meet the challenges of a thermoset or thermoplastic elastomer part. However, a challenge will be 3D printing tires. So here, for example, you can see how much environmental damage that tires that are not disposed properly or need to be recycled can actually be recycled and 3D printed. So the question is the cost and the usage of such type of recyclable 3D printable rubber. Nanocomposites means that we can use carbon nanotubes, graphene, nanoclays, something that's close to what I have originally been doing as a researcher, in that we have focused a lot on nanomaterials for strengthening composites, providing barrier properties, and even applying them for strengthening of materials. So here is a list of some of our papers or publications that are related to nanocomposites and 3D printing. I think I have a list at the end of the talk with references as well. So I'll just give one example, cellulose nanomaterials from the Philippines, okay? We have done some work on harvesting nanocellulose from coconut and abaca, and certainly it- obtaining them as in the form of nanowhiskers or nanofibers, we can then compound them or blend them with polymer materials and resins for 3D printing. So the nanocellulose or whiskers or nanowhiskers or nanocrystals are basically obtained from the broken fibrillar structure of plants. So obtaining them in a high alpha cellulose content from different sources, we actually found that Abaca is unique in that it has some very high content or alpha content of this the alpha helix crystallinity. So in a stereolithographic apparatus method, as shown here, the resin, which is made up of acrylate monomers, we can blend nanocellulose to come up with a thermoset resin composite. So mixing the nano whiskers together with the resin, we can then use that vat of monomers to 3D print certain structures. So for example, we've used it to 3D print prosthesis or thesis implements, including um, devices that are biocompatible. And we have done a lot of this work on nanocellulose, graphene, carbon nanotubes as composites of different SLA 3D printed materials. Another type of polymer that we have done a bit of work are the polyurethanes. So polyurethanes are based on the reaction of uh, uret- um, isocyanates and diols or polyols. The presence of hard and soft segments gives it elastomeric properties. A lot of them are useful for automotive parts, but they have also been used for biomedical implants as well, including the artificial heart and the resins used for dialysis. So TPU polyurethanes are a very important class of materials. So what we've done in this work back in 2017 was we incorporated a nanomaterial based on graphene oxide. We prepared filaments that can be 3D printed. And then by various ratios of the graphene oxide, we were able to demonstrate strengths as well as different tensile properties, compressibility, but retaining its biocompatible properties as well. So as you can see here, the directionality of the 3D printed material, since it's anisotropic, will have different strengths based on the direction of printing. So I guess this is the more exciting part or the more relevant part for PAASE members who are very much engaged in the Philippines. So you may wonder how I started doing things in the Philippines. Well, it's a long story, of course, if I uh, sum all the things that I've been doing through the years. But let me just focus on why Industry 4.0 in the Philippines makes sense. So at this time, of course, uh, we can talk about other things except for the recent pandemic. Industry 4.0 is a catchword for a lot of innovation that will come into many countries as they industrialize and leapfrog current technologies and paradigms. And one of the things I believe that the Philippines deserves to lead is in the area of additive manufacturing. So in fact, almost 5 years ago, I embarked on training different um, personnel. Of course, a lot of them are Filipinos who got their PhD degree with me. But specifically, I worked with DOST shared to have a visiting scholar program dedicated to 3D printing training. So far, if I total the number of people that had gone through my group, including DOST staff, I've trained about 24 people. And most of them have gone back to the Philippines. Some have started their own labs. Some have been teaching 3D printing, start their own companies, and then a number of them are operating the Additive Manufacturing Center at DOST. So I will I will not go individually on the names of these group members, but I think you can just imagine here how many of the Filipinos are represented in my group. More than that, I have actually brought Case Western Reserve University students at that time, when I was still a faculty at Case, to the Philippines. These are undergrads who I brought with me, visiting several universities where I was um, training and showcasing 3D printing to different universities, engaging both undergraduate and high school students on the STEM disciplines, as well as preparing for the 3D printing skills that will be needed by the country. So, for example, as you can see here, this was actually a group of students that I brought with me to Ateneo de Davao. We even visited Philippine Science High School, and you can see that good-looking young man there. That's my son Paul. He's doing a PhD at Rice University these days with Gym Tour. But here is what I have really helped the Philippines for the last 2 years. Through DOST, through Secretary De La Peña and Geb, we helped establish the Additive Manufacturing Center. This is a rendering of a building that was first designed, but I think it looks very different. Nevertheless, the building is set to completion this year, which will house about $8 to $10 million worth of 3D printing equipment. And so several things that you can take home here. One is that this AMCen is probably one of the first in the ASEAN countries to be established as an additive manufacturing center. The only one that I knew that was ahead of us was Singapore. With DOST, this engagement came in working with MIRDC and ITDI and P shared. And I helped lead the formation of this group, but actually the two teams from ITDI and MIRDC are leading the charge in industrial and research aspects of 3D printing. So they call this the MatDev and the Rapid AdmaTech projects. This is funded for now for 3 years up to 2021. Don't know how long it will be, if it will be extended, but the commission has a total budget of 500 million pesos when it was first inaugurated. And the idea is to improve collaboration and develop the ecosystem to work with various industries in the Philippines. Of course, the output will be research projects, collaboration with industry, and different types of output that involves training and growing the ecosystem. So again, this is a summary, a picture of how this AMCen is shaping up. And hopefully, at my next visit there, or when they have their own inauguration and conference, you all will have the opportunity to see what has been done. Now, talking about the Philippine ecosystem and manufacturing, one of the biggest impacts that I see 3D printing going into is in tooling. As you know, any industrialized country has to have the capacity to manufacture its own, whether it's low or high technology. Any manufacturing creates wealth in a country, so simply not importing, not trafficking, not smuggling. These are the things that will build Philippine jobs, will build the Philippine economy. And I'm passionate in seeing 3D printing make an impact because not only it provides jobs, but provides leadership in technology. So I emphasize tooling, manufacturing based on molding, casting, machining, because this traditional forming process is the backbone of things like engine parts, plastic parts, things that can go into assemblies, different types of tolling, assemblies in the semiconductor industry, and so on. The problem is the Philippines cannot easily compete with this in terms of imported manufacturing. And this is because the Philippines is not set up to have very high standards in this manufacturing ecosystem. By leading 3D printing, we can innovate our own design and therefore be competitive in the supply chain industry. So, for example, the disadvantage and advantage of a traditional forming process, as I mentioned, is that it is capital and tooling uh, intensive. However, by 3D printing, one can create new forms or complexes or geometries or even simplified parts fabrication by equipping the designers the ability to use CAD design, use the right materials, 3D print the prototype, and eventually 3D print the tools and the molds. So in rapid tooling, and by the way, we published a paper at MRS Communications with Kokoy on this, in that even a simple plastic injection molding can be rapidly upgraded via 3D printing by learning how to make these molds and dies in a digital process. The savings can be as much as 70% in time and cost. One of the things that we are looking for is in automotive tooling, mold, and design. So, for example, things like thermoforming or casting, or even these tools that are made of metal. So, imagine instead of machining these parts, importing them from Taiwan or Singapore, one can fabricate them in the Philippines and use a digital format to change the design or come up with new designs. That is why part of the training that I gave to the DOST staff was to tour them around the manufacturing demonstration facility at Oak Ridge, where they were able to sample how 3D printing helps the tooling industry in terms of metal and polymer tooling capabilities. So being able to bring this to the Philippines, both the technology, the know-how, and the materials aspect will allow us to leapfrog many Asian countries in the area of manufacturing. As you can see here, some of the staff are looking at robotics that are able to do multi-axis fabrication, as well as different molds that were fabricated by 3D printing of metals. Here at the background, you can see different machines. In fact, an amazing machine here called the Big Area Additive Manufacturing Machine can 3D print wing parts, very big boat parts, or even the keel of a boat, or different types of big areas based on plastic composites. And it's possible to do this today. So that means that you can fabricate these molds, dies, and tools very rapidly, big area. Here you can see me on a 3D printed Jeep. So things that will go into your mind is why do we need to 3D print a Jeep? Well, what's interesting here is this 3D print Jeep design is about 75 years old, meaning by 3D printing, they were able to resurrect a very old design of the original Jeep. The other thing you may ask is what parts here were 3D printed. I would say about 60% of what you see here on this US Army Jeep was 3D printed. So that means excluding the tires, excluding some parts of the engine, and excluding the optics, most of the parts here on this Willis Jeep were 3D printed. So you can see additive manufacturing can impact the Philippines in many sectors, from automotive, electronics, packaging, parts replacement, healthcare, marine industry, food industry, defense procurement, production, recycling technologies. Okay. Even in distributed healthcare and devices. I used to tell the DOST staff, my vision is to see a 3D printer in every barangay. So what that means is that in every barangay, you can 3D print your own prosthesis devices or 3D print parts that normally you'd have to wait and buy expensively. By making 3D printing accessible to the community, I'm sure they'll find many uses for repair, replacement, and healthcare. Even in electronics, being able to 3D print different compact active paste metals and make simplified PCB board designs and semiconductor parts is one of the goals of 3D printing in combination with the right materials. And then finally, robotics, 3D printing of soft robotics means that one can make uh, robotics in terms of soft materials like elastomers or pneumatic types of movement instead of metal gears and arms. 3D printing actually opens the way for robotics or automotive autonomic technologies based on soft matter or polymers. Okay. So again, high value adding, rapid prototyping, and production for the Philippine industries. This is our aim. This is hopefully what we can see in the Philippines in years to come, with cooperation from many sectors, from universities, NGOs, DOST, and of course, uh, infusion of funding from different sources. One can make this ecosystem uh, in the Philippines and make the Philippines one of the leaders in uh, the region. So in summary, 3D printing of new materials. I've shown you some of the important aspects, methods, and materials. The possibilities for the Philippine industries, going from commodity-driven to high-value adding. The need towards high-performance materials, be it metals, elastomers, thermosets, thermoplastics. Now is a good time to see how investments on new machines, training, skills can be directed towards healthcare, defense industries, assembly industries, and so on. And hopefully, this vision is something that we can link up with investment, government initiatives, as well as private investors in additive manufacturing. So, with that, I'd like to thank you, and I'll be happy to answer any questions from PAASE.
Thank you very much, Gobet. That was a very interesting presentation, and it's I think something very exciting for the Philippines if we can really build our capabilities towards additive manufacturing. And we're quite lucky that you're here to help out as well with the training of our researchers and scientists. So, just as a reminder for our participants, we have our chat. So you can type in any comments and questions you may have. And we also have some viewers in our YouTube channel. I'll be taking in some comments and questions from there also. So maybe I'll just begin. I'm more interested when you mentioned about being able to recycle some of this 3D printed materials. So my question would be, is there a reduction in terms of performance or in the properties of the materials once they've been recycled?
Yes, Kay, that's a good question. And it's well known, recycled materials, even through conventional methods, suffer a decrease in performance over time. Maybe the ability to recycle 2, 3, or even 10 times is about the
Mm,
limit. And with polymers, the problem is increasing impurity as well as the breakdown of
yeah.
the original component. So sometimes one has to master batch it with the addition of virgin polymers or other strengthening additives in order to use it again and again. But certainly, recyclable materials can be 3D printed and vice versa. 3D printed materials can be recycled. There is actually a new class of polymers called vitrimers, which can be recycled between what we call a thermoset and thermoplastic in several iterations.
Okay, thank you. So I'll take in one question from the YouTube channel. This one's from Al Serafica. Is there a 3D printed product used commercially in the Philippines? What is the sales volume? And if not, which one do you think will make it and when?
I like that question. Actually, I what I missed giving in this talk, and I'm about to finish a paper on PPEs and ventilator parts by 3D printing. Okay, so if when that paper is published, I'll be happy to spread it to PAASE. Uh, PPEs, of course, have been relevant the last few months because of the shortage of masks. parts for ventilators, intubation, different types of devices for respirators. So if one can quantify how that how much that contributed in terms of value, I think it's going to be large in terms of monetary value. Now, if we're talking about commercial product that's available in the Philippines, I know several entrepreneurs are looking at uh, soles for rubber shoes, 3D printed soles for sports gear as a retail product. But what I've been also hearing is that 3D printing is making its way towards the dental industry in terms of art, temporary crown or different types of model for dental implants and so on.
Okay, thanks. All right, we have our next question from Christina Binag, who's with us now in Zoom. So, on studies of 3D printed face masks using polyurethane, please comment on the breathability and other properties of this material.
Yeah, so Tina, the plastic itself that makes the frame of the mask or other things besides the breathing material or the filter can actually be made from many types of plastics, from PLA to PP to polyurethane to ABS. Although we've found that PLA probably is the right cost uh, strength combination. So in terms of the mass itself, the filter itself, of course, these are melt-blown spun fibers of polypropylene or even polyethylene, and they're the material that makes your 3M mask or your N95 mask. However, what's interesting is some of these materials that have gone to PPE, people have been investigating the addition of silver and copper powders or composites in order to provide more antimicrobial, and of course their aim is to see antiviral properties as an improvement on the material properties of these PPEs.
Okay, thank you for that. Our next question comes from Raymond Tan in YouTube. He says he's asking if it's feasible to 3D print objects with heterogeneous compositions. Is it possible that the compositions will be in gradients?
Yes, Raymond. You have several ways of doing that. You can blend compound hybrid materials, basically composites of plastics and inorganic materials. Or you can direct a multi-material 3D printer to deposit separate materials in layers or aspects of the design. So, for example, you can reserve one area to 3D print metals, and perhaps 3D print on top of it another metal, or you can 3D print one type of polymer in one region or one direction over the other. So either blending or directing the CNC movement and the type of filaments or materials that are printed in a series direction will allow you to have a heterogeneity in both, actually in both materials and design to come up with a better part.
Okay, I have a follow-up question on that. It's quite related. With regards to that, with the machines that are available, how flexible are they in terms of the kind of material that they can actually print? You mentioned that it's possible to do like hybrids and yeah.
Right. So it depends on the starting material you have. If you're working with powders, very fine powders, the typical technique is based on SLS or selective laser sintering. If you're starting with the filament, you will use FDM. If you're starting with a resin based on acrylate monomers or blends, you would use SLA or DLP. And then if you're starting with the paste or extrudable viscous material, you will use direct ink writing or viscous solution printing. So a short answer there is depending on the material, there's a machine out there that can 3D print it.
Okay, thank you. Our next question comes from Richard Abendan, who's with us here in Zoom. So, what has been Philippine industry feedback on the availability of capabilities in 3D printing for tooling? What are the barriers to having industries pursue this opportunity, and which Philippine industry sector shows the most promise or enthusiasm?
Oh, I like this question with many phases in it. Several questions embedded into one. So Richard, the industry we're targeting or we could target is the plastics industry. The plastics industry provide many supplies or assembly manufacturing for automotive, for consumer electronics, for other industries that require a lot of molding, injection molding, thermoforming, etc. So trying to target these industries in terms of convincing them to invest on or work with 3D printing centers capable of producing the molds, the dies based on CAD design, which can replace directly the tools and molds that they usually obtain from metals by machining. So here in the US, we've studied some of this value chain. There can be anywhere from 30 to 70% savings in cost, as well as shortening of the production time to one third when one employs digital manufacturing and 3D printing in the process. So yes, it will take some time to spread that knowledge, but hopefully with let's say the AMCen, that can be a demonstration lab that many manufacturers, um, not only really the plastics industry, but any local manufacturer can see the value of digital design and development of tools, molds, and dies for their own specific industry. One of the things that actually I can add at this point is the replacement industry or the replacement of parts. You know, in the Philippines, there are many old machines that are barely working or is not working because it's missing a piece. And I'm not even talking about just local industry, but even our military, from Air Force to Army, they are looking for replacement parts. And 3D printing has a very high potential to supply these needs because of digital design and the ability to 3D print metals, plastics, and composites.
Okay, thank you for that. We have our next question from Jean Pimentel, who's actually from Colombia. So thank you for that presentation. What is the factor that has the largest contribution on the cost for 3D printing, and how can this technology become more accessible?
Yeah, so the biggest cost is, of course, development of the machines itself. Some of this technology really is quite old, but probably in the 80s, some of the more recent developments were formed, and that has been paid for, meaning the cost of machines are rapidly declining. The R&D is there. So the biggest investment, of course, is that if one goes into 3D printing is the acquisition of the machines itself. Now, the most important investment is really the people, the staff, the know-how. So being able to get trained engineers, scientists to be able to see the gamut of 3D printing and its role in improving design or combining properties of materials with design. That is something that hopefully we will address and train Filipinos for future jobs.
Okay,
And
thank you
other
for
countries too, not just Filipinos, by the way.
yeah. Thank you for that. Yeah, I have a question. So you've been working a lot with the Philippine universities. So maybe one of my questions would be in terms of curriculum, how can we better equip our future engineers so that they will be more capable towards this particular technology?
Yeah, good question, Kay. So, yeah, it is a really loaded question for me because I'm so passionate with helping Philippine education, especially engineering. As some of you may know, I contributed a lot to requiring technical entrepreneurship as part of the engineering curriculum. But what I would say is that if you have a fabrication lab, a maker space in a university, that's a good start. Just having 3D printers accessible to engineers, scientists, architects, or students to play around with to use, that's a start. But probably to formalize it, one can start courses in materials and 3D printing. So, for example, at UT, where I just joined this year, I'm going to start a class in the fall on polymers and 3D printing, which is a way to teach polymer science and engineering combined with 3D printing so that they can see the aspect of materials research and its application to additive manufacturing. So, yeah, establish a lab, a makerspace lab, a design lab, a hub, techno hub, or innovation lab with 3D printers, and then uh, the professors or some of the professors can team teach a 3D printing curriculum. They can combine it with materials research or simply training on CAD design and different types of CNC machine movement.
So you mentioned about CNC. So I know that some of our schools have those old machines, the CNC. So with the advent of this 3D material, so do this go like do they complement each other, or does knowledge in one help progress on the other, or do you think that some of the technology are quite old already and that perhaps we can transition towards the more modern technology now?
Okay, they really do. They really complement each other. I mean, CNC movement, I think numerically controlled movement, that's CNC, is really what they use for machining or different types of machining, milling, or what we call subtractive manufacturing. So when you combine subtractive manufacturing with additive manufacturing, you have the best of both worlds. Actually, the digital design, the CAD design can go both the subtractive and additive manufacturing route. The difference is that the CNC is based on, or machining is based on cutting and lots of waste materials generated. However, the parts you obtained are monolithically strong. On the other hand, with additive manufacturing, you can have more access to complexity in design. But again, it still uses the digital format. So, yes, combining both CNC machining and additive manufacturing is the way to go.
Okay, we have another question from Nikolai Santos. So he's a prosthetist and orthotist and works with artificial limbs and braces. Are there any progress on custom made 3D printed silicone products, specifically fingers and ears? These days, we send them overseas for custom made fingers and ears.
Hmm. Good question. So actually, I think 2 days, no, 2 weeks ago, I gave a talk on 3D printing silicones and elastomers. It's developing. It's actually the technology is there. The material is there as well. 3D printing is possible instead of molding or using them based on a formative manufacturing process. So in this case, if we're looking at a size that can go to a prosthesis or orthesis device for the human body, it's possible. It may not look as nice as, let's say, a molded part, but one can do some finishing to convert it into a very aesthetic looking part. But I would say the technology and material is there to do 3D printing for the medical industry.
Okay, thank you. Is the capability available in the country? Is it available in the Philippines? Sorry.
I don't think so, but I know of several companies that are trying to make it available for the industry. So, for example, before I left Case, I was working with Cleveland Clinic, and
Okay.
they have a lot of synthetic cadavers based on rubber or elastomers. And
Oh.
we were looking at combining 3D printing for medical training, where we can use tomography, scanning, etc., principles in order to combine it with the clinical training with artificial or cadavers based with elastomeric silicone. Because the the feel or the texture of a silicone material is closer to the human body or skin. The other is in terms of what they call virtual reality. So uh, virtual reality training of medical students using 3D printed implements, things like that. So there are many possibilities there. If one can combine this with AI or imaging, and at the same time, if your target is in training medical people, there are many possibilities.
Thank you. The next question comes from Dr. Donna Balela. Is it possible to use 1D nanomaterials as fillers in filaments? They are trying to make conductive filaments by making silver nanowires and polymers via extrusion, but they were unsuccessful.
Hmm. So yeah, if you are looking at carbon nanotubes, nanowires, nanowhiskers, yes. I think the question would be where to start. One can compound them with polymers, thermoplastics, or even use them as a thermoset resin composition. So you will have to decide, first of all, what effect do you want? Do you want them to form a network structure or have directionality in terms of conductivity? If you want them to line up in one direction, then an extrusion process is preferable. On the other hand, if you want a certain percolation threshold based on the network structure that can give you that conductivity, then you will have to make studies in terms of the percentage composition and the corresponding property. And an ideal 3D printing method on that would be SLA, or stereolithographic apparatus.
Okay, thank you for that. The next question comes again from Richard. At Stride, we will be supporting a network of fab labs in academia. What do you think are new services and capabilities that these facilities should look into?
So I'm not familiar with how accessible our design, CAD designs, different types of slicing software is in the Philippines, but that will be a good contribution because I heard that sometimes the ability or to democratize those type of software can be a limiting factor. But in terms of machines, FDM machines are easily accessible, although one would invest in more reliable machines that do not break down easily. But I would say a fab lab which can be equipped with both the software and at least 3 or 4 different types of printers can do wonders. They can explore 3D printing of indigenous materials or different types of materials that can be obtained from the supply chain. And the training with different machines allow them to appreciate both the materials and designs aspect of 3D printing.
Okay, thank you. So I guess we've exhausted all of the questions. Do you have any final advice, words, Gobet, for our audience?
Um, so I didn't catch that, Kay, but
Uh,
I think you were asking me to give my parting shots.
yes, correct.
Okay. Well, first of all, thank you, Kay. This is really a opportunity and a privilege, of course, to talk to our PAASE colleagues and to be in YouTube as well. And my wish, of course, is for everyone to stay healthy, strong, and inspired. Don't be anxious for a lot of things, but move forward. You know, the day is closer than it seems, or the end is in sight. But really, what I would like to say, of course, with regards to additive manufacturing, 3D printing, is don't be afraid to try it. It's easy to get into and will be useful for the next generation. So I hope I'll have a chance to see you all in person one of these
Yeah.
days. Again, stay healthy and be strong.
Okay, thank you very much, Gobet. But before we end this session, again, I want to plug some of our activities. Okay, so let me just share my screen. Okay, so okay. So I want to invite everyone for next week's webinar. So it will be by Dr. Jacqueline Romero. Um, the title of her talk is Ignorance in a Quantum World. So Jackie is part of the University of Queensland, and her main expertise is on quantum world and physics. So I'd like to invite everyone to our 40th PAASE anniversary and 2020 annual PAASE meeting and symposium. So we will be holding the seminars from July 20 to August 14. That's every day, Monday to Friday from 8 to 10 a.m. So if you want details about the program, you can scan the QR code that you see on this slide, and it will take you to our website where you can have more information about our activities and an updated schedule of the program. So we still have our call for papers open. The deadline is initially July 5. So abstract guidelines can be found in this link. And you can email it to paasemanila2020@gmail.com. So we welcome contributions both from PAASE and non-PAASE members. Okay, so finally, you can find us on Facebook. We have our page on Facebook. We also have our website at paase.org and our YouTube channel, which is Paase Webinars at bit.ly/Paase Webinars, where the recorded webinars will be uploaded. Okay, so that's the end of this particular session. So thank you, everyone, and have a good day ahead. Bye.